Hi, welcome to my video. Now in this video, we're most definitely going to do some problem solving. Now let us try to read the questions together. Now question number 11, it reads as follows. The balanced equation below represents the first step in the ionization of sulfuric acid in water. So we are also provided with the equation, the balanced chemical equation between the sulfuric acid and water. And then we see that we managed to form these ions. Now the solution of water and sulfuric acid, it is most definitely acidic. But now, how would you be able to tell that the solution, it is most definitely acidic? It's because on our product side, we have the concentration of hydronium ions. Now the indication of concentration of the hydronium ions or the presence of hydronium ions clearly shows that the solution, it is acidic, because we know that hydronium ions indicates that we have an acid. Now 11.1.1, it reads as follows for only 2 marks. Write down the formulae of the 2 bases in the equation. Question wants you to write down the formulae of 2 bases in the equation above. Now, when we go back to our equation, we can see that here, our sulfuric acid will donate its proton to water molecule. Now, when sulfuric acid, because it is an acid, we know that the acids are the proton donors and the bases are the proton acceptors. So that means this sulfuric acid will tend to be these ions. And then this water, after accepting extra 1 proton, will turn into these ions. So that means between these 2 reactants, sulfuric acid, it is our acid, right? And water in this case will be our base, because you know base are the proton donors. And then when we come to this side of the equation, if we want to reverse the equation, because this chemical equation, it is most definitely reversible. So that means here, these ions will donate a proton to these ions, because we can tell that from the reactants, water has just tended to be this ion after accepting a proton. So if you want to reverse everything, whatever accepted will now donate on the product side of the equation. So this has accepted at first, now will donate. And this donated at first now will accept. So that means here, H3O plus ion is going to be our acid, because you know that acids are the proton donors. And then this, it is most definitely going to be a base to form this. So that means base are the proton acceptors. So now 11.1.1, they wanted us to write down the formulae, not the names, okay? So that means 2 bases, it's gonna be H2O and HSO4 minus ions. Okay, and therefore you get your 2 marks. Now let us jump to 11.1.2. 11.1.2, it says to us, is sulfuric acid a strong or a weak acid? Give a reason for your answer. Now, sulfuric acid, like I said, is supposed to have a table whereby the table shows your strong acids, your weak acids, your strong bases, your weak bases. So now sulfuric acid, it is one of the acids that is regarded to be a strong acid, okay? It is a strong acid. Now, they want us to give a reason. Why do we say a sulfuric acid is a strong acid? Now, this is one of the reasons, okay? So this is the general reasons of all strong acids. The strong acids, we say they ionizes or they ionizes completely in water, okay? This is the reason why we say sulfuric acid, it is a strong acid, is because it ionizes completely in water to form high concentration of H3O plus ions. Okay, so that will be our strong acid. Or you can just simply say sulfuric acid, it is a strong acid. It ionizes completely in water. Just end here. That's still acceptable. Okay. Now let's move to 11.2. Now, 11.1, it was more focused on the theory part of acids and bases, and most definitely 11.2, I expect to have the calculations. So now 11.2, the statement reads as follows. Learners use the reaction of 0.15 mole per cubic decimeter sulfuric acid solution with a sodium hydroxide solution in 2 different experiments. The balanced equation for the reaction is as follows. Now, this is what is happening. These learners, they're going to conduct 2 different experiments. In first experiment, we'll see what will be the processes of experiment number 1. But before we can even go through these questions, now let us write the data provided to us. At this point in time, we are given the equation of H2SO4 reacting with 2 molecules of sodium hydroxide to give sodium sulfate, which is our salt acid and base reaction, and water in this case, which is H2O, right? So now we're gonna run 2 experiments, do not forget that. But before 2 experiments could take place, this is what is happening. They said learners use the concentration of 0.15 mole of sulfuric acid. So for our sulfuric acid in this case, we are provided with concentration, right? The concentration of our sulfuric acid is going to be equals to 0.15 mole per cubic decimeters, right? And then what else it is provided? That's all, right? Now let us read the questions. Now 11.2.1 for 5 marks. It says to us, for the first experiment, they use 24 cubic centimeters of H2SO4. Oh, okay. For A, which is our acid, right? Our acid in this case, this is my data, which is H2SO4. This is what they did. This is the volume of our acid, right? So volume of our acid in this case, it is 24 cubic centimeters. But remember, we're going to have to convert these units to decimeters. So we're going to divide 24 by 1,000. And then you're going to get 0.024 cubic decimeters. Okay. So they use 24 cubic centimeters of H2SO4 in a titration to neutralize 26 cubic centimeters of sodium hydroxide. So for our base, which is sodium hydroxide, our data, once more again, we have sodium hydroxide. So now for our sodium hydroxide, the volume it is thus also provided, I'm going to say VB, which is volume of our base. It is provided to be 26 cubic centimeters. We're going to convert it to decimeters. It's going to be 0.026 cubic decimeters. So again, for our acid, from the original equation and original data, we are also provided with the concentration of our acid. In this case, concentration of our acid is going to be 0.15 mole per cubic decimeters. So now the question here says to us, calculate the concentration of the sodium hydroxide. Like I said, for 5 marks, we want to calculate the concentration of sodium hydroxide, meaning we want to determine the concentration of our base in this case. So what is happening here? This reaction will take place under the titration. So now when we undergo titration, there must be a substance that we call a standard substance, okay, or standard solution. So in this case, between our acid and base, which one is a standard solution? It is our acid, which is H2SO4. Why do we say H2SO4? It is a standard solution because it has a known concentration. But in this case, our base doesn't have a known concentration. That means it is not a standard solution. So a standard solution, it is a solution that was prepared prior titration. Before titration could be taken place, a standard solution was prepared before that. And therefore, this standard solution will help us to determine the concentration of the unknown substance, in this case, which is sodium hydroxide. So that means experiment number 1, they calculated they ran titration so that the end products can help them to determine the concentration of the sodium hydroxide. Okay, so they read a volume while they were running titration, not the concentration. Concentration will be performed using calculations like we do right now. Basically, these are the experiments from this is the data from the laboratory. They have already ran titration, which is working out on these calculations as scientists. Okay. So now, when we want to calculate the concentration, we're going to use that formula of titration, which says the stoichiometric coefficient of acid divided by the stoichiometric coefficient of base is going to be equals to concentration of acid multiplied by volume of acid divided by concentration of base multiplied by volume of base. And therefore, now we're going to do our substitutions. So these are the coefficients. These are the stoichiometric coefficients from the balanced chemical equation of this titration, of this neutralization reaction. So now, what is stoichiometric coefficient of acid? In this case, it's going to be most definitely 1. So I'll just use this base over here. We have 1 over 4 base. In this case, it's going to be 2. You're going to have 2, which is equals to concentration of acid. In this case, it's going to be 0.15. And therefore, volume of acid in cubic decimeters, most definitely is going to be 0.024. Therefore, you divide by concentration of base is what we are basically looking for. Now, what is the volume of base? Volume of base, it is provided to be 0.026. I really do not have enough space. I'll just utilize this space over here. Now I'm going to cross multiply. I'm going to say 1 multiplied by everything here. It's going to be everything there, which is CB multiplied by 0.026, which is equals to this multiplied by 2. I'm going to say on my calculator, 2 multiplied by 0.15, 0.15 multiplied by 0.024, and therefore this is what I get. I get 7.2 times 10 to power -3. And if I'm going to divide this by 0.026, both sides of the equation, and the concentration of my base, I'm going to say answer divided by 0.026, and therefore I get to 2 decimal places, 0.28 mole per cubic decimeters. Per cubic decimeters. Okay, -3 there. So this will be the concentration of the sodium hydroxide. So that's what they did for experiment number 1. Okay, that's what they basically did. All right then, so let us move to experiment number 2. for 8 marks. Okay. So now in another experiment, 30 cubic centimeters of the H2SO4 is added to 20 cubic centimeters of 0.28 mole per cubic decimeter of sodium hydroxide solution in a beaker. Calculate the pH of the final solution. Now I'm going to rewrite the very same equation over here, okay? So we have H2SO4 reacting with 2 molecules of sodium hydroxide to form or to produce an Na2SO4 and water, which is H2O. Now, this is experiment number 2 now, okay? Remember, the concentration of sulfuric acid, it is the same as that one that they started with, okay? So here our concentration, it is 0.15. I'll just write them here, okay? I'm not gonna write the units. And then the volume now, it's gonna be, remember we converted it to cubic decimeters. The volume now, it's gonna be, what is 30 divided by 1,000? I think it's gonna, let me do it, 30 divided by 1,000. It's gonna be 0.0, yes. It's gonna be 0.03. This is our volume, okay, in cubic decimeters. And then again, we are also provided the information of sodium hydroxide. Now here, our sodium hydroxide, now we also know its concentration. It's 0.28 mole per cubic decimeter. And then the volume, it is most definitely going to be equals to 20 cubic centimeters, which is 0.02 cubic decimeters. Remember, we convert that, okay? Right. So in experiment number 2, they mixed up these two reactants, and therefore they wanted to determine the what? They wanted to determine the pH of the solution. Okay, they wanted to determine the pH of the solution. Now, this is what is happening. The solution could be acidic, or the solution could be basic when determining the pH. The thing about this is that between these two reactants, we do not know which one it is the limiting reagent, which one it is the excess reagent. So now this is what we are going to do. Between these two reactants, we are going to determine the limiting reagent. Now, after determining the limiting reagent, we're going to know that the one that is not limiting reagent, that means it is the excess reagent. So during this chemical reaction, the limiting reagent will be used up to form these products. And therefore, the reagent that is in excess is going to left behind in the very same solution, okay? In the very same solution. And therefore, between these two, that excess reagent that's going to left behind will give the pH of the whole solution. So that means the pH of the solution, it depends on the excess reagent. The pH of the solution depends on the excess reagent, because the excess reagent, we're going to have the one that is going to left out. As that one left, and therefore will affect the pH of the whole solution. So let us firstly determine the limiting reagent, okay? But before we can do that, we're going to use this data to determine number of moles first, okay? That's what you're going to do. So to solve question number 11.2.2, we're going to determine number of moles of this, okay? Number of moles of our acid in this case is going to be equals to C multiplied by V. Now the concentration of our acid, it's 0.15, and then the volume is 0.03. And then when we punch this on our calculator, we're going to say 0.15 multiplied by 0.03, and therefore we get that our number of moles is 4.5 times 10 to the power negative 3 moles. Now let us determine number of moles of our base in this case, which is sodium hydroxide. You're going to use the very same formula, C multiplied by V. And then in this case, our concentration is 0.15 0.28 multiplied by volume is 0.02. Therefore, when we punch this on our calculator, 0.28 multiplied by 0.02, we get that it's 5.6 times 10 to power negative 3 moles. Okay, so there is a longer way to determine the limiting reagent, but for now I'm going to show you the quickest and the simplest way. There are 3 steps to determine your limiting reagent. Okay, so to determine the limiting reagent, we're going to determine firstly number of moles as we did, and therefore we're going to divide this number of moles using the stoichiometric coefficients. Okay, so we're going to say number of moles of acid divided by the stoichiometric coefficient of acid. In this case, it is most definitely 1. Here we have 1, and therefore is 2. We're going to use number of moles of our base divided by the stoichiometric coefficient in this case, which is 2. And therefore, now as I continue, number of moles of our acid in this case is equals to how much? We have just calculated. It's 4.5 times 10 to power negative 3 divided by 1. 2, number of moles of base is going to be 5.6 times 10 to power negative 3 moles divide by 2. Now, when we punch this on our calculator here, we're going to get 4.5 times 10 to power negative 3 divided by 1. It's going to be 4.5 times 10 to power negative 3. 2. Therefore, here we're going to say 5.7 divided by 2. We get 2.8 times 10 to power negative 3, right? So now this is what we see. This number is greater than this number, okay? So now we jump to the third step. The first step, we calculated number of moles. The second step, we calculated the what? The number of moles using the stoichiometric coefficient. The third step, we are comparing now between this number of moles and this number of moles, which one is greater. We can see that 4.5 times 10 to power negative 3, it is not less, but it's greater. It's greater than what? It is greater than 2.8 times 10 to power negative 3. Now, for a fact that we have greater number of moles over this one, so that means this will be in excess, because this we have a lesser number of moles. That means this is a limiting reagent. So remember, to get this number of moles, which substance did we use? We used the base. Okay, remember this comes from the base, number of moles divided by stoichiometric coefficient of the base. So that means in this case, sodium hydroxide is the limiting reagent. Okay, so that means sodium hydroxide, it is the limiting reagent. That means sulfuric acid is an excess reagent. Now, after determining between the two, which one is the limiting, which one is the excess, so now this is what we are going to do. Okay, that means H2SO4, it is in excess. Remember, question wanted us to calculate the pH of the final solution. The final solution is going to be acidic because of excess H2SO4 that is going to left behind when the reaction has been completed. So that means now this is what we are going to do. We need to determine number of moles of H2SO4 left behind, so that they can help us to determine the concentration, and that concentration will help us to determine the pH of the solution. So now, according to this balanced chemical equation, how many number of moles of sodium hydroxide do we need so that they can react with this? We most definitely need this number of moles. Where is it? We just calculated it. We're going to need this number of moles from sodium hydroxide, right? We're not going to take this. This is just helping us to determine which one is greater, which one is less, by dividing by the stoichiometric coefficients. So this is the actual number of moles that we started with for sodium hydroxide. And therefore, let's see how many number of moles are needed by sodium hydroxide from the sulfuric acid. So according to a chemical balanced equation, stoichiometric coefficient, we're gonna say here we actually need this, but let me show you it can calculate that. So according to a balanced chemical equation, the ratio we have 1:2 stoichiometric coefficients, and therefore number of moles of sodium hydroxide, which is this, it's we said it's 5,6 times 10 to the power negative 3 moles. And therefore here it's what you're looking for, number of moles of let me just write acid, which is needed. So you're going to say this multiplied by that. Here we're going to have 2Na, sorry, number of moles of acid. 1 multiplied by that is going to be that, which is 5,6 times 10 to the power negative 3 moles. And therefore, you divide both sides by 2, we're going to get this. That's why I said you don't even need to do that. So that means number of moles of acid in this case is going to be equals to 5,6 divided by 2. It's 2,8 times 10 to the power negative 3 moles. So that means this is the number of moles that we need from H2SO4. So basically, we do not need 4,5. It is through the original number of moles that we've started with, that we had at the beginning for H2SO4 was this. Okay, so this most definitely it is the initial one. Okay, so this, it is the initial one. So that means to determine the excess number of moles, you're going to say number of moles of acid left behind is going to be equals to how much? It's going to be number of moles of acid initial that we started with, subtract number of moles of acid that is reacted, because this is going to react out of 4,5. Only 2,8 is going to react with sodium hydroxide. So the initial number of moles is going to be, which is this one, it's 4,5 times 10 to the power negative 3, subtract the reacted number of moles is 2,8 times 10 to the power negative 3. And therefore, when we punch this on our calculator, 4,5 times 10 to the power negative 3, it's going to be 1,7. So we get 1,7 times 10 to the power negative 3 moles. This is number of moles of our acid left behind, or you can just say number of moles excess. Okay, I love saying left behind. So now with this number of moles left behind in this solution, this didn't react at all. So we're going to take this number of moles to determine the concentration of the final solution. But do not forget, this number of moles, it will be suspended in what volume? In a volume of, remember, this and this, when they combine together, they give a volume of 5, because this plus this is going to give a total volume of 5, 0,05 cubic decimeter. So plus the excess H2SO4. So this is the product side, whereby we're going to have this, which is going to give the acidic solution to this equation, to this final solution. So meaning we have how many number of moles left behind? 1,7 suspended in what volume? In a volume of 0,05, which is the combination of this, which form the products. Okay, so that means we're going to say concentration of our acid, it's going to be number of moles divided by volume. So now number of moles is 1,7 times 10 to the power negative 3 divided by volume. In this case, it's 0,05, 0,05. And therefore, what will be our concentration? I'm gonna say this divided by 0,05, and then we get that our concentration, it's 0,034 mole per cubic decimeters, right? So now this is our concentration. But I want you to bear this in mind. Let me write it over here. The concentration of H2 H2SO4, we just calculated it. We said it's 0,034 mole per cubic decimeter. So bear in mind, this concentration is a concentration of H2SO4. But remember, H2SO4, because here we have water, this H2SO4 will ionize to form hydronium ions, right? In order for us to determine the pH, remember, we're going to use that formula that says pH is equals to negative log. Since when we have our acid, we're going to use concentration of hydronium ions. So that means this acid needs to ionize first. So according to this, we know that H2SO4, as it ionizes in water, it will form H3O plus ions plus what? Plus SO what? SO4 minus ions. I understand this is diabatic acid. It's going to donate all of the electrons. This is the final equation, basically. We know that it has to donate that first, and then secondly will donate that first. But let's just balance this equation. So on this side of the equation, we need how much? So that means on this side of the equation, or let me just write it in this way. Okay, let me just start it in this way so that you can understand. Let me just start it in this way. I should have erased this one. So let me just write it in this way. So now check. So it's gonna ionize this in water and then to form this. So this is going to donate this to there, and then we're gonna have H3O plus ion, and then that will turn into HSO4 minus ion, right? And therefore, we're gonna undergo the second reaction. But let's just balance everything first, okay? The charges are balanced. Let's see the number of moles. We have 2 plus 2, which is 4. We have 1. We have what? We have this one. We have this one. There are 4 as well. Oh, we need how many? We need here we have 4. We have 1. 4, 1 is balanced. Therefore, we take this, which is HSO4 minus reacts with water once more again, and it's going to form what? This, when it donates that, it's gonna be SO4 2 minus, plus this will turn into H2SO. What am I writing now? Let me do this. Let me write it, this one on the side of the equation. Eh? So okay, this will donate a proton. This will turn into H3O plus ion, plus this one will turn into SO4 2 minus ions. And therefore, if we try to balance this equation, how many hydrogen? We have 3. We have 3, right? We have 3, and then oxygen, how many do we have this side? Here we have 5, and then here we have also 5, right? The charges are also balanced. Now, the overall equation, that means this, when it reacts with this, it will form this as an overall equation. So that means H2SO4 plus H2O will yield to form H3O plus ions plus SO4 2 minus ions. Now let's check if this equation it is balanced. Okay. Here we have H2, we have 4 hydrogens, and then here we have how many number of hydrogens? We do not have 4 rather, but we have 3. So that means I'm gonna write 2 over here, so that this 2 multiplied by this 2 could be 6. So here I need to increase my number of hydrogen atoms. I'll just write 2 over here to affect, I don't want to affect sulfur because I can see that sulfur is 1 over there. So I'm gonna write 2 over here. That will only affect oxygen, so because I'm gonna have 2 oxygens. You see that? So that means let's see, we have 6 hydrogens, we have 2 multiply by 2 is 4, 4 plus 2 is 6, hydrogens are balanced, sulfur 1, 1, oxygen we have 4, 2 multiplied by 1 is 2, 2 plus 4 is 6, 2 multiplied by that and 4 is 6, and the ions, the charges are also balanced. You're going to have 2 positives, 2 negatives, they give 0, it's 0. So that means this is the overall equation. Basically, you're not supposed to do this. I'm just showing you because I know some of people, they get confused where does 2 comes from. So now, remember, this is, you do not need it when you're answering the question, okay? I'm just reminding you where is everything coming from. Remember, we just determined the concentration of H2SO4. We're going to use this concentration to determine the concentration of hydronium ions. So according to a balanced chemical equation, stoichiometric coefficient, we have 1 is 2, there we have 2 for hydronium ions, 1 for our acid. And therefore, we're going to say concentration of H2SO4 is to concentration of H3O plus ions. We cross multiply, and therefore we're going to have 2 multiplied by H2SO4, and therefore this side we're going to have concentration of, and then this side, we're going to have concentration of what? Let's see, we're going to have concentration of H3O plus ion, because remember, 1 multiplied by that is just that, right? And therefore, remember, we just calculated the concentration of H2SO4. It was 0,034 is equals to concentration of H3O plus ions. Therefore, concentration of H3O plus ions will be equals to how much? You're going to say this multiplied by 2, and then we get 0,068. Now let's determine the pH of the solution. So I'm going to utilize this space. pH is equals to negative log concentration of HO plus ions, and therefore you just say negative log our concentration. In this case, it's 0,068, and therefore final answer, the pH will be equals to how much? Let's see, we're gonna say negative log answer, and therefore we get that the pH is 1, to 2 decimal places is 1,67 to 2 decimal places is going to be 1,17. Remember, the pH doesn't have the units, and therefore this will be our final answer.